Hi, this is our part three critical thinking project. I am Jamal Anderson.
And I am Adrian Calixto.
I'm Nevaeh Hernandez. And the movement that we chose to do was performing a squat. So for the biomechanics, the prime movers would be the gluteus maximus and the quadriceps. For the prime synergists would be the hamstring, adductor longus, and magnus. And the prime stabilizers would be rectus, abdominis, obliques, internal and external, transverse abdominis, and soleus and gastrocnemius. The joint position and arm levers are this equation right here. As for force, it would be the push and pull to create the actual movement. For torque, it would be twisting that causes a rotation. And for lever arm, it'd be a bar that rotates around the joint. And how form changes alters muscle demand. It would change mechanical advantages and amount of force that muscles must create. And within a squat, this is done to maintain balance so that the muscles can contract.
And so when performing a single squat, the phosphocreatine system is the most dominant energy pathway. And so the slow twitch oxidative fibers are the fibers that are recruited first from the body. And as the force and intensity increases, that's when the body starts to call upon the fast twitch glycotic fibers. And so what this means is that the muscle fiber that is ultimately used depends on the intensity and force needed for that action. Since our action is only a single low intensity body weight squat, this means the slow twitch oxidative fibers will be recruited.
Right. So the way that cross bridge cycling generates force is during the squat, skeletal muscles like the quads contract as mouse and heads attached to the actin and pull them inwards. This repeated cross bridge cycling shortens the sarcomere and it generates tension, allowing for the quads to move. Mouse and heads require ATP due to remove itself from actin after a power stroke. ATP hydrolysis reclocks the heads for the next cycle. And when ATP runs low, the muscle cannot relax, which leads to fatigue. Sustained contractions occur when holding the squat in a position. Muscle and heads continue to cycle, but the muscle length does not change. Repeated contractions occur from the up-down motion of each rep. Actin and myosin slide past each other, shortening, and they lengthen the sarcomere each rep.
So for the problem solving, we did improper squat depth, and how the muscles will be overloaded will be due to the limited hip engagement from the poor squat depth to the quads will take on more loads and the knees and patellar tendons take on more stress and the lower back may have to compensate.
And so the phosphocreatine system would be the energy system that fails first because it is responsible for providing immediate energy for the first few reps. And so with poor form, this system will fail faster because anaerobic glycolysis to take over faster, leading to faster fatigue.
Right, and in the cells, when there's not enough calcium, this can impair contraction efficiency and fatigue fibers. ATP depletion, it will not allow cross-bridge cycling, and it can reduce the power output.
As for reducing injury of risk, we would have to practice the full depth squats slowly, focusing on form, mobility, and the core strength. Thank you.